Hello everybody, and warm welcome to the Blockchain Technology and Applications course offered by the University of Nicosia for the Master's degree in Digital Currency. This is an introductory video for session 3. In this session, we will talk about different categories of blockchains. What are some of the properties of public blockchains compared to private or consortium ones? While they are all called blockchains, most of the time they have quite different properties. We will begin our session with a brief overview of public blockchains. There was an empirical analysis made in 2017 by Bartoletti and Pompiano, and they found out that there are not that many public blockchains that are operating already. A lot of them are still in the pre-release stage or are even still raising funds before actually developing them. Some of the announced platforms probably won't ever see the light of the day at all. Then we will move to the introduction of smart contracts, which will be described in much more detail in later sessions. When we talk about blockchains nowadays, it is almost implied that smart contracts are a part of that. However, much like a blockchain, they can mean different things to different people. Besides the relative complexity of transactions in Bitcoin, which can be called smart contracts too, usually we mean that smart contracts are more general purpose than just payment processing. And when general purpose smart contracts are discussed, Ethereum was actually not the first implementation of that idea. A Turing-complete cryptocurrency, which means that it provided an arbitrary complexity to the transactions, was made in 2013, and it was called Xcoin. It was designed by Sergio Damian Lerner. Only later in that year, in 2013, Ethereum followed with the idea of enabling a wider spectrum of transactions beyond the transfer of value. Ethereum set the bar for general-purpose public blockchain platform very high, calling itself a world computer. We will make an introduction to Ethereum and will continue to get to know Ethereum better through the following sessions in this course, as well as some challenges that it has and is trying to solve, either by improving its platform or by building a broader ecosystem around it. Then we will discuss the properties of non-public blockchains, private and consortium blockchains that make them different from public ones. A case for public blockchain will be our first subject. Now we need to remember what was the original premise of blockchain. It was designed to support a peer-to-peer currency in Bitcoin, and it was designed to support shared data and shared logic in Ethereum. Blockchain technology first worked in an open network, enabling uniform access to all its participants. And one of its strong features was censorship resistance. Now, in a private blockchain, where the participants are known and carefully authorized to use it, censorship resistance loses its meaning in a way. For some time, in the earliest days of blockchains, considering blockchain in a private setting was quite controversial, and sometimes it still is. Private blockchains are about protecting confidential data, and it is not just about the senders, receivers, and the amount of transferred value. It is about protecting contracts, business logic, metadata. There's the dilemma of whether a private blockchain can be used even within one company, and we will try to consider some options for that. Now, consortiums, on the other hand, seem much more suitable for using blockchains, as in general, they share the same regulatory requirements and comparative business goals, and aren't able to blindly trust each other. So members of a consortium share a portion of their business data, but instead of each maintaining their own ledgers, they could all work on the same ledger, distributed among them in a secure way. Thus, reconciliation, inconsistencies, or other ambiguities can all go away. A consortium blockchain could be understood in terms of business process optimization. Then we will talk about Hyperledger, which is one of the most prominent organizations for non-public blockchain projects, having more than 200 members. It aims to bring together various projects under the same roof, so as to enable a better interoperability between them and ensure a more structured and even standardized way of developing blockchain platforms. It has a great potential to bring some order to this nascent field. Then we will take a look at some ways that different blockchains could be connected to share data, to exchange value, to timestamp data onto another chain, onto another more secure chain, and so on. So we will briefly describe what anchoring means, which is sometimes used to submit a hash from data of one blockchain and commit this hash to another blockchain, usually a public one. Followed, we will describe what is pegging, which is used with minor chains to exchange value or to enable more features of a main chain. There are some options of how to design pegging to be secure and efficient, but the details would be out of the scope for this course because it can get quite complex to study these things. Transactions across different ledgers are another thing that will be groundbreaking, and while that might take some time to make it ready for mass use, we can hardly imagine all the possibilities that might come with that. From streamlined, decentralized cryptocurrency exchanges to interoperability of smart contract platforms, and even to changes to the economic models for those platforms. With cross-chain operations, we are getting into much more complex waters than we had when Bitcoin was the main talk on the street. Interesting projects in this space are Interledger, Cosmos, OmiseGo, and Polkadot. Lastly, we would take a look at how would a blockchain look without blocks and without chains. At least that is the case with Corda. But to understand Corda, we need to first understand what are Ricardian smart contracts, a concept few years old that can link the real-life legal data with a virtual one, the one that is digital only and lives on the blockchain, or better, on the distributed ledger. So with that, we can talk about Artery Corda. We will see briefly how it works and what it enables. In the last part of this session, there is a brief overview of various deployment platforms. Now, We can launch blockchain nodes on our own computers, on our own hardware, but an interesting and quite aggressively marketed option is to deploy blockchain nodes in the cloud. We will discuss a little bit about that, and you are also encouraged to share your opinions on the matter, or you can share your experiences if you are already using these options. We will mention the offer from Microsoft Cloud Azure for Blockchain as a Service, which is an offer which Microsoft is working on for some time now. They also introduced a new concept called cryptlets, or secure code execution. You could say a way for a secure execution of smart contracts. And finally, there is the Cocoa framework, recently announced by Microsoft. Can you guess what Cocoa stands for? So one of the largest consortium projects launched in March 2017 is called Ethereum Enterprise Alliance, or ENTF, with more than 200 members. It is a modification of Ethereum for public blockchain to the enterprise environment. There are a number of working groups already established, from banking to digital identity, legal industry, supply chain, and also tokens. And perhaps most importantly, there's also a standards working group as well. This concludes this session. Hopefully we have raised your interest in these topics. You are invited to share your opinions and comments on the forums. For any questions and any other help you might need, please don't hesitate to reach out and write an email. Thank you and happy studying!